Well, we talked last time about the scientific revolution and thinking about the history of the people and the developments in that sequence of events, right? That inspired Newton to say that I stand on the shoulder of giants. So one after another. One of the elements, one of the effects, the gifts, if we will, of the scientific revolution is the scientific method. Now, I know that McClellan and Dorn are talking about it. I know that your videos just assume that you know what they're talking about. But one of the things we want to do in this short video is to talk about certain definitions, certain word choices that you're going to come across, and how those help us to understand the way scientists think about cause and effect, the way scientists think about problem solving. So let's start with some of our definitions. You'll see from time to time in your reading, and you'll also hear from time to time in some of your videos, the word axiom. An axiom, or a postulate, is a premise or a starting point in reasoning. So an axiom is a starting point in reasoning, or of reasoning. As classically conceived, an axiom is a premise so evident as to be accepted without controversy. An idea, a premise, a fact, so evident as to be accepted without controversy. The word comes from the Greek axioma, that which is thought worthy or fit, or that which commends itself as evident. I am 6 feet tall, Cheryl Golden said to you. Among women, I am considered to be tall. That's evident. That's an axiom. As used in modern logic, an axiom is simply a premise or starting point for reasoning, which we've already said before. Some of these ideas come from Wikipedia. That's where my quotes come from, so I wanted to make sure you knew that. Abstract thinking. We've been talking about the idea of abstract thinking as we move into the scientific revolution, as we move into the idea of scientific thinking or pure science. Abstract thinking is the final, most complex stage in the development of cognitive thinking, in which thought is characterized by adaptability, flexibility, and the use of concepts and generalizations. Say that again. We'll develop this further as we go along. The final, most complex stage in the development of cognitive thinking, in which thought is characterized by adaptability, flexibility, and the use of concepts and generalizations. Problem solving is accomplished by drawing logical conclusions from a set of observations, for example, making hypotheses and testing them. There you see the connection easily between abstract thinking and the scientific method. What if? Why is this the way that it is? You have a video to look at as well after this one that is from Khan Academy again, and the question there is, why does fresh water freeze at a different freezing point than salt water? What's going on? Is it the salt? Is it something else? Abstract thinking, asking questions, making hypotheses, and testing them. The empirical method. We have seen the word empiricism. We have talked about the idea of observation. The empirical method employs the doctrine that all knowledge is derived from sense experience. That which you see, which you hear, which you taste, right? Perhaps even that which you perceive, such as an earthquake, right? You kind of feel an earthquake. You experience it. Therefore, it exists. Now, we're going to also talk a little bit today about deductive reasoning versus inductive reasoning. Deductive versus inductive. Deductive reasoning, a method of reasoning from a general to a particular. It is employed in deriving general laws or principles from the observed phenomenon. I always think of this as having a large overarching idea, claiming that, and then using that idea to understand a smaller phenomenon, something that you see, right? So, method of reasoning from the general to the particular. From the general to the particular. Inductive reasoning. A method of reasoning from the particular to the general. The mental process involved in creating generalizations. That we hold off on making generalizations until we can see smaller versions, if you will. So, starting with the particular, starting with the small, and then going towards more general. As you might imagine, this is one of the hallmarks of the scientific revolution. So before we get to Descartes, let's go back a bit. Deductive reasoning, a method of reasoning from general to particular. It is employed in deriving general laws or principles from the observed phenomenon. Inductive reasoning, a method of reasoning from the particular, the small, to the large, to the general. The mental process involved in creating generalizations from the observed phenomena or principles. All right, let's go to René Descartes. It has been said that René Descartes is sort of the beginning of modern philosophy, the beginning of modern mathematics. That all of this sort of began with René Descartes. He is from France. He is in the late 16th, early 17th century, and so he is contemporary with some of our great thinkers in the scientific revolution. He's a philosopher. His analytic method of thinking focused attention on the problem. His analytic method of directing, perhaps that should say, focused attention on the problem of how we know. His analytic method of thinking, focused attention, I should get my inflection properly. His analytic method of thinking focused attention on the problem of how we know. This has occupied philosophers ever since Descartes. How do we know what we know? How do we know what a fact is? How do we know? Do we argue from large principles down to the small? Or do we argue from small ideas up to the larger theory, the larger generality? Descartes, this was his approach to problem solving, his understanding, his way of trying to figure out how we know what we know. The first rule, he said, and this is from his book, Discourse on Method. Again, we're talking about the scientific method and its development. The first rule was never to accept anything as true, he says, unless I recognize it to be evidently such, an axiom. That is, carefully to avoid precipitation and prejudgment, and to include nothing in my conclusions unless it presented itself so clearly and distinctly in my mind that there was no occasion to doubt it. First rule number one, right? The second was to divide each of the difficulties which I encountered into as many parts as possible, and as might be required for an easier solution. So let's break it down into its particulars. Let's break it down to its individual phenomena if we can. So, never accept anything as true unless I recognize it to be evidently such. And second, divide each of the problems, each of the difficulties I encountered into as many parts as possible, and as might be required for an easier solution. Third, the third part of his method was to think in an orderly fashion, beginning with the things which were simplest and easiest to understand, and gradually and by degrees reaching toward more complex knowledge, even treating as though ordered materials which were not necessarily so. So trying to find order, right? And even treating things as ordered, even though maybe they didn't present themselves that way at the beginning. This is abstract thinking, right? Last, always to make enumerations so complete and reviews so general that I would be certain that nothing was omitted. Being very clear, being very thorough. Always to make enumerations so complete and reviews so general that I would be certain that nothing was omitted. So looking at the very small, the very detailed, but then also stepping back and looking at the big picture as well. Another great figure in the development of the scientific method, a contemporary with Descartes, is Francis Bacon, and Bacon is from Scotland. His work, the Novum Organum, helps us to understand something about the scientific method as well. True science, he says, progressed in a just scale of ascent, and by successive steps, not interrupted or broken, we rise from particulars, he says, to lesser axioms and then to middle axioms, one above the other, and last of all to the most general. Again, axioms, self-evident ideas, self-evident information. He's going to say lesser and middle, not to worry, we'll move into that in a moment. But true science progressed in a just scale of ascent, right? Ascent is a climb up. By successive steps, not interrupted or broken, we rise from the particulars, the small, to a little bit bigger, and then a little bit bigger still, one above the other, and last of all to the most general. So he suggests that the first thing you do in the scientific method, so-called, from Bacon, is accumulate a store of particular empirical observations. So make observations. Secondly, from these, inductively infer, going from the smaller, lesser axioms. Some have suggested that this is, in our modern understanding of the scientific method, an hypothesis. Again, we'll get to that in a moment. So accumulate a store of particular empirical observations, and from these, inductively infer axioms. From these axioms, inductively infer middle axioms, higher axioms, if you will. And most folks who follow the scientific method, the modern version, say perhaps this is getting us to a theory. Fourth, and then propose the most general of notions, each in progressive steps. So start with the observations you have for whatever your problem is that you're trying to solve. From those, starting with the smaller, try to find axioms. Try to find self-evident concepts. From those, move even higher, and then finally get to your generalities. Some have suggested if we read modern meaning into the language used by Bacon, we might see a foreshadowing of the idea of a hypothesis in his lesser axiom and a theory in the middle axiom. This would make his method agree with the mature conception of science in use today. However, the context indicates that his ideas were not yet so fully developed. So there is controversy as to whether or not Sir Francis Bacon is the father of the scientific method. He's a philosopher. He's trying to do problem solving. He's trying to think in an orderly fashion, right? From the smaller to the larger. So I have a few more definitions for you, and then some help from a scientist up in Wisconsin. Every scientific experiment, every scientific experiment starts as a hypothesis. Right? Every scientific idea starts as a hypothesis. This might be his lesser axiom. According to Merriam-Webster, a hypothesis is an idea that hasn't been proven yet. If enough evidence accumulates to support a hypothesis, it moves to the next step, known as a theory, in the scientific method, and becomes accepted as a valid explanation of a phenomenon. And that might be Bacon's middle axiom. Right? So, hypothesis. Every scientific experiment, starts as a hypothesis. According to Webster, a hypothesis is an idea that hasn't been proven yet. If enough evidence accumulates to support a hypothesis, it moves to the next step, a theory, in the scientific method, and becomes accepted as a valid explanation. All right. So I'm going to Michael Blaber, who I believe is out of Wisconsin, and he's got an interesting example, I think, to help support this. So a hypothesis, he says, a tentative explanation or an idea about how things work. Hypothesis. And a hypothesis guides you in further work to get a better answer. Example of a hypothesis. The moon is made of cheese. Note he says, this is the kind of hypothesis my wife would come up with. Okay. How could we test this hypothesis? The moon is made of cheese. That's our guess. Well, we want to test, so we're going to do some data gathering, some empirical Evidence gathering, and we're going to experiment. Construct a rocket to go to the moon and return with some samples. Make a cheese pizza, substituting the moon samples for the cheese. Ask people, he suggests graduate students because he thinks, they're disposable. Sorry, you're undergraduates, you're made of gold, we would never do this to you. Ask people to eat the pizza and see if they can tell any difference from pizza made with real cheese. And again, he's trademarking the folks in Wisconsin because that's where he is. Most likely conclusion, hey, this pizza tastes like dirt. This pizza tastes like dirt. New hypothesis. Alter to include additional information from the above experiment. The moon is not made of cheese, it is made of dirt, sort of like the Earth. Theory. A theory is an explanation of the general principles of certain phenomena with considerable facts to support it. A theory remains valid only if every new piece of information supports it. If a single piece of available information does not support a theory, then the theory, as proposed, is disproved. Again, a very important part of the scientific method, yes? So, the moon is made of cheese. If you could go to the moon and you could get some moon material and make a cheese pizza out of it, once, and twice, and 3 and 4 times, and it always tasted like dirt, you'd probably be doing all right. But if for some reason somebody actually managed to bring back material from the moon that somehow made a passing connection to a cheese pizza, we might have to reconsider the theory. A fact. A fact is an indisputable truth. Example. It is a fact that on June 30th, 1908, in Tunguska, Siberia, an explosion equivalent to about 50 million tons of TNT occurred. That is a fact. It happened. It is a theory that this explosion was due to a natural extraterrestrial phenomenon and not to an activity associated with man. One hypothesis is that a comet collided with the Earth. A competing hypothesis is that a small black hole collided with the Earth. Interesting. So 2 hypotheses, difficult to test, given that time has passed. But the main theory is, until they come up with some kind of fact, which they seem not to be able to do, that suggested that human activity caused that explosion, there was evidently no evidence that they could find to point to that. The theory is that the explosion was due to a natural extraterrestrial phenomenon and not to an activity associated with man. Interesting. So, we're coming to the end of this presentation on the scientific method. We've looked at definitions for axiom, empiricism. We've looked at some ideas about deductive versus inductive reasoning. We've looked at the fathers of the scientific method with Descartes and Bacon, and then we've walked through some of the basic ideas of an experiment and how scientists use this method to come to knowledge. Please continue to watch the videos in this session, and including a couple more examples associated with the scientific method. Off we go.